Hello out there. In the last few weeks, we had a series of discussions on various topics related to architecture. And this week, we would be shifting our focus towards setting up an architecture for a new application. And to discuss that, I have with me Koushik and Shiva. Welcome, Koushik. Welcome, Shiva.
Hello, Ranga. Hi, Koushik.
Hello.
One of the frequent things that we talk about when we start discussing about a new application, new setup, new architecture, and things like that is we focus a lot on language, framework, tools, and all those kind of aspects, right? I feel one of the most important aspects that we need to think about when we are starting a new application is modularity. Thinking about what are the functional modules you need to have, what are the technical modules that you need to have, how do you organize your application. And probably that's where we will start our conversation today. Kaushik, do you want to give an high-level overview on what is modularity, why is it important, and what are the different factors that you would consider when you are deciding the modules for a specific application?
In my mind, modularity is a way for you to deal with a complex architecture and a complex application by breaking it down into smaller pieces. When you have something very complex, it's hard to make sense of it. It's hard to reason, right? There are lots of, like, you take a big application, a big architecture, a lot of different concerns that you have to deal with. Modularity allows us to split it into smaller, simpler components that work together to form the bigger architecture. Now, when you break something down into modules, it's also important to partition it right, because you want to make sure that when you break something into a module, it is kind of reusable and self-sufficient. And in some sense, a lot of the things that you would apply to code, like breaking something into a method in a class, right? You want to make that method self-sufficient. You want to make that method have a single responsibility, and you want to have clear interfaces for that method, like what goes in as an argument, what return type is. So some of the same concepts also apply to breaking things down into modules. You have a good interface that surrounds the module so that it can be used, reused, and extended when needed. So that's at a high level what modularity is to me, and a way for you to break down a complex application into simpler, reusable components.
Absolutely, yeah. It's basically a way to make things simple by breaking down a complex problem into maybe small sub problems with clear, distinct boundaries for them, right? Shiva?
Yeah. So when you are thinking about building a complex, large application, it is highly likely that there is going to be more than one subsystem within the application. So when you are designing for a new system, you have to identify what is the main goal of the application, and there will be subsystems who is going to support that main goal of the overall architecture. So you need to break it down, thinking of those subsystems, and then come up with how they can integrate with each other in various protocols and all the stuff. But yeah, that is going to be the first step you need to think about when you are coming up with a architecture for a new system. Uh, yeah, identifying boundaries, subsystems, and how each subsystem communicates with the other component in the overall system. So that's where I would suggest to start.
Absolutely, absolutely awesome. In terms of modularity, right? Whenever we talk about modularity, there are a couple of terminology which are frequently used, right? Coupling and cohesion. I guess these are also applicable when we talk about classes, like when we talk about even maybe at the method level also. But coupling and cohesion are much more important when we talk about at a high level, at a modularity level, right? For example, when we let's say how we do authentication or how you do authorization. If I have multiple applications in a specific enterprise, I don't want each of them to be worrying about authentication and authorization. That's why what we do is probably break it down into a separate component, which would be probably reusable across most of the places. Kaushik, given that context, like how do you look at coupling? How do you look at cohesion? And how do you use them to make decisions?
Uh, the funny thing about coupling and cohesion is, for a long period of time, I used to mix up the two. It's like I would use one for the other. But basically, the essence is, like, you don't have to use the terms exactly, but the concept is what's important. So coupling is basically when you have two different modules or two different components, and you're having them interact with each other. It defines how two modules are related to each other, right? And cohesion is what is happening inside a module, how closely connected are the things inside a module. So basically, when you're creating modules, you want to make sure that two things that are related to each other should be in one module, right? What if two things are supposed to be together, put them in one module. Two things which are not supposed to be together, don't put them in one module, right? It's simple common sense. Obviously, it makes
Exactly.
very much of sense when you think about it that way. So when you put two things that belong together into one module, you have a cohesive module, right? It's like it works together. Everything in that module knows about what the other thing is, and they're supposed to work together, supposed to know each other. That is cohesion. When you have cohesive modules, right? Things are together where it needs to be. Coupling is relationship between modules, right? You see, we talk about decoupling, right? What is decoupling? You basically means that you want two modules to not be so tightly coupled to each other or tightly related to each other. So coupling is a property of two modules, and how much one module is dependent on the other module, how much it needs to know what the other module does, how much the other module is important for this module to exist. So that is relationship between modules. So as you can probably tell, one of these two is good and one of these two is bad. Okay, when you have modules that are cohesive, that's actually a good thing, right? Because you are putting two things that need to be together inside
Right.
one module. So the module is cohesive. At the same time, when you have a lot of coupling, that is a bad thing because it means that you have one thing in one module dependent on another thing in another module, and these two modules need to know what each other are in order to work. So they're very tightly coupled, which is generally a bad thing. There are some cases where tightly coupled is a good thing, but usually with architecture and different modular in modularity in general, coupling is a bad thing. So the general rule of thumb when it comes to architecture is lower the coupling and increase the cohesion, right? Low coupling, high cohesion. So that's coupling and cohesion.
Perfect. Low coupling, high cohesion. And one of the best examples, probably where we can see coupling in play, probably is the JPA story, right? So, like when your application is making use of Hibernate, for example, then you are tightly coupled to Hibernate. But if you're making use of JPA, which is kind of an interface, your application is now decoupled from Hibernate, but you are obviously coupled with JPA, but you have the flexibility to change from Hibernate to some other framework. So it's, as you say, Koushik, I think it's at multiple levels, and the choice is not obvious. Like a lot of times we think coupling and cohesion are easy. Deciding what is the right cohesion to have, and when it becomes tight coupling, the boundary of that is not really clear. And a lot of times it's very ambiguous. Shiva?
Yeah, and the same concepts like coupling and cohesion that you apply to the classes and methods, you can also apply at the overall system level. There are multiple components of it, and how one is heavily depending on other, or how loosely coupled it is from another. So the same concepts apply at the architecture level. But the tricky part is hitting the right sweet spot of uh, correct balance where a module does not tightly couple to another is not so easy. Like most of the times we make significant decisions at the start of the project. And that is the time when we have least amount of knowledge how it is going to evolve. So it is going to be like takes a lot of iterations over and over again, and then refine over the time so that it is kind of a loosely coupled, and then you can build modules with a high cohesion. Like it's iterative process. Like sometimes if you think about the microservices, right?
Right.
Either you may go with a monolith where you put multiple unrelated things into a single system, or you go ahead aggressively and split everything apart, and then for every functionality you at least make at least 2 3 microservice invocations. That's kind of what you are saying. You go ahead and aggressively split it too much, you have to bring them back together. So those are the
Exactly.
kind of indications that tells you, okay, there is something that needs to be refactored to have independent and cohesive modules.
Absolutely. So, touching upon microservices aspect of it, right? So, probably microservices is kind of taking the same thing, modularity, to the next level. Like instead of not just having components, but you are actually even independently deploying those components. And that's where the decisions that we would need to make are, like, should that be a component which should live with the application, follow the same release process as the application, or should it be a separate microservices? These are decisions probably which are tough to make, and probably that's the reason why you focus on probably building components, individual components as part of the same application, or individual modules as part of the same application, so that at a later point in time you have greater flexibility onto how you would deploy them. Is that how you look at it as well, Koushik?
Yeah, no, that makes a lot of sense. It's there isn't like a rule that you can follow. It's always tricky with where you draw the line. And what's even trickier is, as the requirements change, what was once a cohesive system now, or cohesive module, now becomes a coupled module with something else, right? Because these things are never static; it keeps changing. So yeah, it's you have to kind of constantly reevaluate it, and there's always trade-offs involved. So yeah, definitely agree.
Absolutely. Absolutely. I think as far as the technology goes, probably a lot of times components related to technology are much easy to identify. Authentication component or the authorization component. So those aspects kind of stand out, and probably they can be individual components which you can have across the enterprise, because those are technology standard components which you can use. But functionally, when it comes to breaking down into different modules, that's where there is a lot of challenge, because probably you don't have the right understanding, as Shiva said at the start. When you start developing an application, you don't have the right knowledge to decide what are the functional modules that you would have in a specific application. All right, that's cool. Probably let's shift down one level further. Like, one of the ways we actually kind of bring in modularity into our, especially Java based applications, is to have multiple layers for the application, right? So you have multiple layers, like a web layer, a business layer, a data layer, and things like that. Shiva, what's your take on layering? And why do we do layering? And like, where do you see it going forward?
So layering is for separation of concerns. Like typical in most of the applications, it is like MVC, where controller, service, and then repository or DO, whatever. So this is the usual pattern that I notice in most of the applications, just to separate out the concerns, where you have this controller layer which accepts a web request and then unpack all the data payload and then call service layer, where you perform all the business logic. And if there is any interactions to the database or any external systems, you delegate the calls to a repository layer. So it is very commonly established and most commonly used pattern. But the thing is, over the time, you split all this into controller, service, and repository. But if you organize your application code in this layer-based approach, where when the application starts, right, it looks fantastic, like you have clear separation of it and all. But as more and more features getting added to it, the other controller might need some information from some other service, and then they start calling this service, and then again this service A wants to get some information from some other repository. So slowly, while evolution, like it is like it goes into one thing calling multiple, it basically become like a many to many communication. It kind of a very tangled. So the remedy is to follow package by feature and then package by layer, where you group all the feature related things into one high level module, and then you can talk to another module based on service boundaries on service interfaces. You don't just poke into others repository just because you have access to it. So that's how you need to package it by feature and then package by layer. uh, I see it is, it prevents this getting tangled over the time.
Absolutely. Yeah, I think you are touching over two important very concepts there, Shiva. I think one is separation of concerns, and the second aspect was using packages, uh, the package definition of a specific class as a way of, yeah, as a way of actually separating out what you can do in a specific thing and what you cannot do, like using packages as a way to decide the boundaries. So over here, like, when we talk about layering, we actually talk about having maybe a jar, a separate layer, as a way to like identify the boundary, and the packaging inside that layer is the second aspect that you're bringing in, where you can use that as well to decide the boundaries. Kaushik, how do you take that?
I totally agree. There are, we have had a kind of shift in the way we package these things. Earlier, it was, previously, before we had all these microservices and all that, the monolith was mainly a standard three-tier architecture, at most four-tier architecture. You had like a front end, a service tier, data tier, and then it goes talks to the database. So mainly what was happening there was, one, it was basically bound, packaged by uh, what the technical capabilities of the team is, right? There used to be like dedicated, backend developers who would mainly work on services. There would be the data team who'd work on databases, and then create stored procedures and all that. So there are like dedicated teams working on these individual things. This is now kind of transformed into what we call vertical slicing now. So you don't really say, okay, this is the mid tier anymore. You look at, okay, what are the features that we want to build, and look at a feature, form a team around that feature, and then each feature will have some presence in the front end, the mid tier, the back end, and perhaps even the database and so on. So this move towards having these autonomous teams, like, okay, you team completely own this feature, don't bug other teams about this. So something like that. So you have, uh, because of this reason, because of this change, we now tend to have more of these kind of like, you start with the domain, identify what the problem is, start with the domain, package with that, and then move on to like, okay, which part of this needs to be in which tier. So you kind of start from the package onwards to the tier.
Absolutely, absolutely. So it's like first you would organize by the feature, and then you would probably layer it.
Yeah.
So it kind of so I think that's one big shift in the last few years, right? When I started off as well, I was more used to packaging by layers. So you have a data package, a business package, and kind of it. Now we have the feature first. So the feature one, feature two, that becomes the package name, and whatever sub packages are under it, like the technology becomes a part of a specific feature, kind of, which helps you to solve a specific problem. Awesome, awesome. Kaushik, one interesting aspect, I mean, we are talking about modularity and layering. One interesting aspect I would want to bring in here is the modularity of the Java environment as such. Right? There was, like with Java 9, there was a big change with respect to the technical. I mean, this is little different. This is kind of, probably we are going on a tangent, but Kaushik has done interesting work there. He has also written a book on modularity of Java. So Kaushik, I mean, how does that relate to what we are talking about in here?
There is a relation in terms of how you want to think of modules as this kind of having an interface and the implementation, right? Yes, I did write a book, but nobody bought it, Ranga. It's
I have it.
not many people.
It should be
Oh, you
somewhere
did.
here.
Yeah, I can see that sitting on the bookshelf there somewhere.
Oh, here.
um, no, that's fine.
Okay. It should.
um,
No, no. It should be here. It's
yeah.
here.
um, there is this idea of a package in Java that is comprised of a group of classes, right? It's almost like a one level hierarchy above classes. You can have a bunch of classes, interfaces, all those types inside a package. The problem has always been that a package is just for organization's sake. Right? You just give it a name and say, okay, all these things are related together. It's almost like you're tagging it. There's nothing that happens in a package. Of course, there's package private and all that stuff, but people hardly use it, right? Most of the times you end up with public and private because you don't know if another class in that same package basically means that that class has full access to the thing, right? Package private usually ended up becoming something you would use for testing, right? It was just, that was the only thing you would use it for. Put a JUnit test in that same package somewhere else,
Right.
and then you have access to test. That was the only use of package private, really. So there was a lot of discussion in the community over how can we make a certain class restricted to only a given package, and say, okay, I'm building a library. I want this to be the interface for anybody who's consuming this library, right? I want to be able to say, here is my API for the library, but all these other classes are private to the library. I don't want any consumer using it. What ends up happening in Java is once you develop the library, you provide a nice, documentation and say, hey, folks, use this API, don't use something else. You give them the jar. Well, all the classes in the jar are sitting in the class path. So it's kind of free for all. Anybody can use any class. So this ended up being a common problem, not just for library authors, but for the JDK and the JVM itself, right? So the Java library that comes with all JDKs and JREs, well, JDKs really, contains a lot of classes which are not public documentation. They're not supposed to be used, but people end up using that anyway. So they introduced the Java modularity system, JPMS, a Java platform modularity system, to provide a solution for it. You can now put classes in a package and say this particular class is usable only by a certain module. You can define a module that's kind of an additional construct, and then anybody outside the module cannot access what you've called module private, and you can only allow certain classes to be accessible outside the module. So it is a step in the right direction. This allows us to say we are packaging by feature is one way to do this. We can say I'm going to create modules by feature, but at the same time you can also insulate what anybody outside the module is using, so that if somebody is not allowed to use a certain portion of the module, you are free to change it as a package author.
Exactly.
So it is not necessary. Using Java modules is not necessary for you to create modules in Java. It is just that it makes it easy for you to enforce what the contract of the module is. And if you use
Absolutely.
modularity right, you're going to have less coupling because you control what the coupling is when it comes to somewhere else. Cohesion, yes, kind of, it allows for it, but the main impact is going to be in the coupling in the conversation we had earlier.
Absolutely, absolutely. So, like that's another good example of setting rules around what can be done and what's not, and the boundary is very, very clear. So, I think that's a great example of that. And one another impact of the Java modularity system, uh, Kaushik, is like the containerization aspect of it. Right? Earlier, it's like the entire JDK or nothing, but now you can probably pick and choose which aspect of the JDK you'd want to make use of, so that the containers you build are kind of smaller, right? So
Yeah.
I think, yeah, go ahead, Koushik.
Sorry, yeah, that's a great point. Because you can now pick and choose what you need. The whole Java platform itself is now broken into modules, and you can have a very lean Java runtime that contains only the modules that you need, which is, I think, vital and honestly not being as well used as its potential is in terms of microservices. You can have really lean Java runtimes for your microservices. So your cold start times are going to be super fast. Rather than loading the whole Java platform, you just load
Exactly.
what you need. So for like lightweight microservices, that's a big boon. I Unfortunately, people aren't using it so much. I think it is still a very promising technology that will catch on once people realize the value of it.
Absolutely, absolutely. I think as we head more into the container world, the memory consumption, the startup times, and like those kind of aspects become really, really important. And your jars, your runtime cannot be as big as it was earlier. And yeah, I think those aspects will be in the focus going forward. Shiva, let's. I think we are touching upon a lot of aspects around modularity layering. Another typically talked about aspect is domain model. So, what are your thoughts on domain models? Like, when do you use them? When do you not use them? Generally, what are your thoughts at a high level?
Uh, Domain modeling is like when you start the project, you talk to the business, right? What exactly they want to build. In that discussion, you can identify what they are talking about, and then you can identify what are the key domain aspects they are interested in. Like suppose you are building an e-commerce application, obviously you will have a discussion with business, and they talk about products, they talk about customers, they talk about orders, they talk about shopping cart. So all these key aspects is nothing but a domain model in terms of the application, right? So so they are like key aspects of it, but on top of it you need to think about how the interaction among all these, and who are the actors that are going to use the system. So you need to come up with a flow like, okay, these are the actors that are going to use our application, and these are the mechanisms they are going to interact with our system, and how and where we want to store our information, and what kind of interface we are exposing to other parties. Like, okay, it is a web-based communication system, or is it going to be a messaging-based communication? So you think in terms of those, and then you build the core interfaces, not the concrete implementation. That becomes your core domain model. You have business entities, you have various models that enables you to communicate with this core domain. So that becomes the core domain part of it. And on top of it, if you think in terms of a clean architecture or hexagonal architecture, ports and adapters, whatever comes as part of those layers is nothing but how you expose yourself to the public, be it a front end, be it a mobile app, or any other system. So
Absolutely.
that's the key part is coming up with the core domain and then
Okay.
modeling those aspects into your system.
Okay. One interesting aspect you touched upon there, Shiva, was the hexagonal architecture, right? So, like, hexagonal architecture is kind of a alternative, or maybe something which can sit along your layered architecture. How do you see it?
So there is a lot of confusion. Like there is a clean architecture from Robert C. Martin, Uncle Bob, and then there is a hexagonal architecture, and then a variation of it is like adapters and ports. But there is kind of a difference. But when you think in larger picture, it is like you have your core domain where you embed all this business logic into it, which doesn't depend on actual concrete thing. Like you talk to a persistent storage, but you don't actually implement that database interaction in that core part of it. Most likely you implement it as an interface. So you should be able to take that core domain and then attach any mark or actual real implementation of it, and then you should be able to run it. So also the interaction part, you should be able to interact with a CLI or web request or messaging, so that those all parts, communication channels and all are abstracted away, and you have this central piece which contains pure business logic, and you have all these aggregates and then repositories. I mean, all the abstract implementations, not the concrete implementations of it. So
Absolutely.
that is the
Absolutely.
key aspect of it. Whereas if
Good.
you think general three-tier architecture, where you have controllers and then service and then repository, and your repository directly talks to your database. Take, for example, Spring Data JPA, it kind of talks to the database. It's like you introduce another layer of indirection so that you can test the core part of it without having to set up a database or anything. You don't even have to mark it. Mark in the sense using H2 or any test containers. So it enables you to test the core business logic without having to set up all the infra related stuff.
Okay. Okay. So with the hexagonal architecture, you would actually give more importance to the core, and you kind of build all the other things as kind of maybe something
Plug
around
and
that.
play. It's kind of a plug
Absolutely.
and play model. Like you have the core domain and you have
Absolutely.
interfaces to communicate to it, and then it's up to you. You are going to build a REST API on top of it, or you are going to build a CLI, whatever that works.
Okay. Okay. Yeah, I think that's a very interesting aspect. Just going a little further down, right? When we talk about Java, typically, right, most of the Java classes have just getters and setters and no business logic. Do you see use of domain models in that space? I mean, where like it's not just anemic Java objects, but more like have kind of a really representative domain model that represents the exact business structures or even the entity structure. Kaushik, how do you see that going in the last few years?
Um, I don't quite see a direct relation between those. You do have, you can have Java classes contain the logic. At least I'm probably not as well versed with hexagonal architecture as Shiva is, and I think I have a question for Shiva after my answer. Um, I feel like it's not that tightly related. Like you can basically, like, you have your core business logic. You can basically build it anywhere. You can have stateless Java classes which implement that business logic, or you can have specific workflow using some kind of a workflow engine. It could be any of those things. The whole point of hexagonal architecture is just that the core is supposedly not as quickly changing, or as likely to change as some of the other components. The core is essential to the business. You kind of put that in the middle, and then all the other things are kind of like, like Shiva mentioned, plug and play, and they are supposedly a little less, sustaining, right? They're supposedly short-lived. So that's the basic idea. Like you can build it however you want. It could be, the core could be Java classes which contain the logic, or it could be stored procedures in a database. The plug and play models could be again Java classes, or it could be something else. So it really depends on how you implement it with that concept. I also want to draw an attention to listeners or watchers. Even though it says hexagonal architecture, it doesn't, the six doesn't mean anything over here. It's basically the shape. I've had people ask me this question. This is usually confusing to people, right? It's not that there are six things. It's basically the shape where you have one center and then all the things on the edges. It could be 10, it could be 3 or 4 or whatever. But yeah, the principle is what it is. Implementation could be anything. Yeah.
Yeah. I remember something like orthogonal architecture. Is that somewhere related or not, Shiva? And Kaushik, what's you had a question for Shiva?
I had a question for Shiva, which is related to hexagonal architecture. One of the problems with hexagonal architecture is that it assumes that the plug and play items are independent of each other, right? So that's the whole point of plug and play. You don't want to have one plug and play item to be dependent on another plug and play item. That has traditionally been a challenge in a lot of companies, where you have like two plug and play things share some component, right? So what usually people end up doing is they kind of put it into the core because it's like, if it's in the core, both can share it. But that's usually not ideal, because you don't want to do that. You want to start from the core and then build outside. So the challenge, and I want to hear your thoughts on it, Shiva, is how do companies, in your experience, manage that sharing? I've heard people talk about like build layers, and there is something called onion architecture as well, right? So you basically think of it as layers, and then one layer builds on top of the other. I'm curious to hear what your experience has been, Shiva, in terms of having dependent such components in a hexagonal architecture.
So when we think about either clean architecture, onion architecture, or hexagonal architecture, if you think in terms of a core domain, like again, I'm going to answer Ranga your point. Do we need setters and getters and all, right? So when you modeling this core domain, the very idea is any class or any component within the core domain will always be in a what do you say in the right state. Like for example, you are modeling a bank account. So obviously there won't be a bank account object which doesn't have account number associated to it, right? But if you have, say, you have a bank account class and then you have setters and getters, you can create a bank account class empty object, and then you can call set account number, set this and set that and all that. But before calling all these setters and all, you have an empty bank account object which is invalid. That doesn't make any sense. So to exist a bank account object, it should have all the mandatory properties already set. So you take all the required properties as a constructor arguments instead of using setters and getters. Also, when you are making any operation on top of it, you always ensure that this model state is in a valid state. It should never go in an invalid state. You do whatever operations, you call any business methods or anything, it should never in a inconsistent state. It should always be from one valid state into another valid state. Whereas why we have these so-called classes with setters and getters is kind of a, mostly my understanding is because our framework requires it. Like you have starts Spring MVC, or I think these days that's not a limitation also. But they need these setters and getters so that it will automatically bind your request parameters to those values. So these are kind of a framework needs, not actual requirements. But and also some people use the same entities core domain objects as part of their request binding objects. So that's why people tend to blur this distinction between what is core domain and what is request objects, response objects, those things. And coming to your point, Kaushik, like this shouldn't contain, this core ideally shouldn't contain anything that is specific to the delivery mechanism. Like, and again, when we think about in theory, we can say, okay, I have this core domain and anybody can use it, be it a mobile app, REST API and all. But most of the times it is going to be a REST API. There is no CLI client ever. But the idea is, anyway, you are going to implement it. Why not just decouple it? Separate the core domain, and then you have this additional layer as a separate module. Like you are exposing REST API. Yeah, you can expose this REST API. And if any multiple clients trying to use your core domain as a module or something like that, I would say just have a different implementations. Don't tie multiple things just because they are sharing some common things. Just don't try to put into the core domain, because that's how this feature creep happens. Okay, today my mobile client needs a slightly different feature. Okay, let me put a flag here. If it is a mobile client, I'll do this. If it is a web request, I'll do this. So that's how this nastiness creep into the core domain. So I would suggest to just prevent that. And then it's okay to have a bit of duplication than leaking all those kind of nastiness into the code domain. Uh, I understand the importance of don't repeat yourself and all those things, but at times having a bit of duplication is far simpler than leaking those things into the code domain model. If it is too much of duplication, probably there is another layer you can abstract it away. But in the initial design, should not leak that aspect of delivery mechanism into the code. Yeah, we have in one of our previous project, we have this model hexagonal architecture where the core domain uh, is untouchable. Right? It doesn't have anything that is related to HTTP or anything like that. There is no dependency on any database drivers, any HTTP components, nothing. It's just core domain. And then we have another layer for mobile client and then web client, all this there is a bit of 20 to 30% of duplicate code, but that's okay. When you think in terms of evolution, they evolve in a different speeds and different directions, so it's fine.
Yeah, that makes sense. Thank you, Shiva.
Cool. I think we are talking about modularity, layering, domain model, orthogonal architecture. So those are kind of the most important decisions that somebody needs to make when they start off with developing an application. Now, let's move on to the typical decisions that we make, right? Choosing language, choosing frameworks, those are kind of the sexy parts of doing, like building a new application, like usually, right? So, Kaushik, like what, like let's say, like let's probably set a little bit of context. Let's say you are building a REST API right now, and let's say you have, like you have the freedom to choose the language, frameworks, how do you want to architect it, and things like that. So how do you go about with that? Let's take a simple REST API.
It's if you give an example like that, that ends up getting into controversial territory, Ranga. It's like I'm saying, okay, if you're building a REST API, you got to pick this framework. There isn't really one obvious choice, as most people can realize.
Absolutely.
I think there are certain criteria that play into any technology decision. The first criteria is, of course, uh, inertia. It's the biggest criteria that goes into any architectural decision. What has the company slash team been doing for so long? No matter how awesome a new framework is, no matter how cool the features are, it's going to take a lot for an architect to say, let's get rid of what we have been using for the last 5 years and let's switch to something else. So usually what ends up happening is an architect makes a decision like, okay, we have people who knows, let's say it's a Spring shop, right? The architect goes, we have people who know Spring Boot, they have the experience, they have a code
Right.
base, so let's just pick Spring, right? As long as there are no red flags that usually ends up becoming the case. Because imagine working for a company where this project A uses Spring, project B uses something else, project C uses something else. So it's a very hard. So I think, as glamorous as this technology choice decision is, it usually goes down to inertia first. If you're starting
Absolutely.
from a clean slate, which it's every architect's dream to be able to start from a clean slate, because that's where the most fun is.
Yeah.
Then all these questions come into the picture, right? First is, what is the most industry standard for solving the particular problem, right? Because at this point, there are some industry leaders for each of these categories. So for example, if you take something like REST APIs, Spring is probably the first thing that comes to mind. You
Mhm.
can, as an architect, say, I'm going to pick Spring, and I don't have to worry about regretting my choice later, right? Because it's an
Absolutely.
industry standard, and you can always justify 5 years from now, for some reason, Spring is not the right choice. You can say, well, everybody picked it. It was the right choice at the time, right? So it's a safe
Mhm.
option.
Absolutely.
Now, if you have multiple decisions to make over there, then it comes to other ideas, other factors, like how easy is it to hire people, right? You don't want to pick a not popular technology and have a struggle with, like, okay, I need to get people on board.
Mm.
Again, if you have people already, inertia plays into the picture there as well. And then after that comes the features, functional and non-functional requirements. How easy is it for you to satisfy those functional and non-functional requirements? And from there on, there are other areas where you get into it, like, okay, how would you deploy it? Then it comes to the build and deployment time. Let's say I want to put this application on on some serverless instance in the cloud. Well, okay, how is the cold startup time? How is the cold boot time? Does one
Exactly.
framework help better than the other? So those are the questions that come to mind at that point. But as appealing as this is, those are usually at the very end, realistically speaking, at least in my experience. An architect doesn't go like, okay, we're all like 50 developers working on Spring. There is a new framework which saves us 2 seconds of startup time. Let's switch. That never happens. But yeah, so there
Exactly.
is this progressive decision making process that you go to, and eventually, once you have like a fork in the road, that's when you would be like, okay, now I have two which are equally appealing in terms of all the previous decisions in the process. Now,
Mhm.
when they're at the same level, then let me look at the next step and pick one from that. So that's how my experience has been with choosing architecture. How about
Absolutely.
you, Shiva?
It, the choice depends on whom you ask. If you ask a developer, the answer could be, if they want to be in a safe zone, they might say whatever is they are very much familiar with. They will say, I use that technology. But if you are asking a manager, the concerns why they want to pick a particular technology is, as Kaushik mentioned, they need to think about allocating the people to that project. They need to have people with that skill set. So their way of thinking would be like, do I have people with that particular skill set? Otherwise, it's going to be a challenge to hire them. So a manager's point would be a bit different. And again, a lot of things takes place. Like, suppose if you ask me as an architect, I would say I would pick whatever is right for this particular problem at hand. But it's not that simple. Like, let's say I am working as an architect in so and so organization, and over the time we are building. Let's take an example of, okay, most of our applications are based on Java. Okay, so then it's not about just building the application. It is putting them in production and making sure they are run fine, right? So a lot of effort goes into tuning the JVM, tuning the garbage collection, and a lot of knowledge builds over the time. When you think about building a new system, they also consider, okay, now somebody wants to build this in Go, but do we have that kind of expertise in supporting those systems? Do we have enough knowledge in making and tuning for production needs? So that aspect also comes into picture. So it is not simply building some shiny thing or anything like that. There are a lot of things come into play, and inertia, right? Yeah. Suppose let's consider I'm a business owner. I want to build some application. I have a bright idea and I want to build an application, right? And what would be my concern? I want to build something application as quick as possible, and I want to put it in production to evaluate my idea. Is this a valid one? Okay, somebody can come and say, okay, Go seems to be faster than Spring Boot. Shall we go with Go? But see, there are a lot of things you need to build, whereas with Spring Boot, a lot of things comes out of the box. I don't care how fast it is. My idea is to evaluate my idea, my business idea. I would suggest to go with Spring Boot, which comes with a lot of out of the box features. So the technology choice is not purely technical; it involves a lot of managerial and business decisions also. But if you
Absolutely.
ask me as an architect, I consider team skill set. Yeah, we can say developers should be open to learn new things and all. Yes, that is fine, but we need to consider ramp up time. Okay, we all like to learn Go or Rust, anything, any new technology, but do we have that much time? If yes, wonderful. Otherwise, we have to pick something which is proven to work. We need to go with it. So, yeah, a lot
Absolutely.
of things come into picture when choosing a technology stack.
Okay.
Yeah, and also
So
we, in the previous talks, we had conversation about how an architect is no longer an individual contributor. They're looking out for the team, right? So this is another one of those things where it's like, even if you are excited about working on a technology, that may not always be the right choice. You got to look for what is it that makes the team succeed, and this includes, like Shiva mentioned, what can how can we be quickest in terms of time to market? How can we help the manager acquire resources, because they're also a part of the team, and
absolutely.
it's all a partnership. So it's a more nuanced decision sometimes, and I'm sure every architect will have it at some point in their career. Your choices will not be popular. Okay, sometimes you're going to have to make choices, and the developers come and go, well, you picked the wrong thing, it is not cool. Here's a cool new technology. So there is a part of getting people on board as well as a part of the technology choice. You not only pick the technology, you also have to sell it to all the stakeholders, including the developers, including the manager, or whoever else who is involved there.
Absolutely.
A,
Absolutely. I think
a true
I faced a
story.
lot of challenges. Sorry, go ahead, Shiva.
A true story. A few months ago, we have a discussion, architecture discussion, technology selection discussion with a potential client, and then they already want to build with Node.js. And then, okay, I asked why. Is there any particular reason? The reason they said is like it is hard to hire people if I say we are going to build in using Java and Spring Boot. I asked why it is so popular, and they said there is a misconception, I would say, like Java is kind of a very old and complex and beast, and all the cool developers want to build with either Go or Rust or Node.js. They don't want to work with Java, and that is the single reason they are having a hard time hiring the developers who are willing to work on Java projects, and that is the reason they are choosing the Node.js. See, that's how complex choosing the tech stack is.
Absolutely. Absolutely. A lot of things which we don't think are important are the most important things which decide which technology you make use of. Right. I mean, a lot of times, like Kaushik said, you like when you make unpopular decisions, uh, conveying them to the team plays a how you take it to the team also plays a very important thing. Like long back, like this was time when easy mock was much popular framework than mockito. So like mockito was just the fresh kid on the block at that particular point in time, and mockito did not work in Java versions less than 5, and we were using Java 4. And that was a place where like we had a few existing tests in easy mock, not a lot, I mean very few, and people were comfortable with using easy mock. But I found mockito to be better. I mean, this is kind of very small part, but this is like a place where I thought, okay, we are going to write good unit tests, and I feel like Mockito is a better unit testing framework than EasyMock. Uh, Getting that change across like almost like took me 3 or 4 months, and by the time there were even more tests which were written using EasyMock, and it becomes even more difficult as it goes on. So yeah, as you say, like making technology choices, improving like the technology decisions which are made over a period of time in a specific project are more than just the technology decisions. A lot of other factors come into picture. I guess in the interest of time, like I actually wanted to talk a lot more about making technology choices, but I guess in the interest of time, probably we'll just switch over to the next thing, which is to, like, you are, let's say, building a brand new application, and let's say you have a team of couple of people to get started with. So what are the things that you would focus on when you start implementing the project, right? So you'd want to make sure that probably you have the right setup. You'd want to make sure that probably, like, you have a like a reference slice, or like kind of the like you're talking about most of the important like probably like the way, like I look at it is like you look at the risk and probably identify the highest risk factors for a specific project, and probably those are some of the things that you'd want to address in the initial phase. How do you go about doing that, Kaushik?
Um, it's a hard question. Usually, when I start a project, I I spend some time to define what the success criteria is. What is success for a project? When do we
Mm,
know that we have done what we are set out to achieve, right? Because that's fluid and that'll change. When we start out thinking, okay, we want to do this, and more conversations, more meetings and all that stuff, and things just start to change. So at a core level, what do we want to achieve? So I'm going to start from there. Once I do that, we're going to look at what you said makes sense. We're going to look at what are the risks involved, what are the challenges involved in getting that done, and if there are any metrics that we can track to say, okay, this is like, let's say we build an e-commerce website, and the success criteria is not just that the website is up, but that we have the ability to serve these many number of users. We are able to scale to these many number of users, right? That kind of gives us a good starting point. This is usually more necessary when you're working in a startup environment than when you have like an established business where they do have like a very good idea about it. But it usually helps to start that, and from there we look at what the user experience is. I'm not talking about like the what the web page looks like or stuff like that. It's basically the user journey, the user experience. What does it How does the user come to the application? Like, what is the touch point? What does the user do? And from there on, and this also involves a partnership with the corresponding people, right? The product owner, the user experience teams, kind of identifying what the ideal user experience is. Because oftentimes we start out with requirements um, which are like, okay, this needs to be done, but when you actually chalk it down to the user experience, things are very different. So
absolutely.
starting with basically setting up the goals, setting up what needs to be done, that's how a project starts. And
Mm,
from there we kind of go down into the, like, what are the functional requirements, what are the non-functional requirements, and from there the whole technology discussion, the team staffing discussion, all those things go from there. So this would be my starting point. What is a project? What defines its success? What are the risks involved? And in as a part of what defines success, like, what are the metrics where we can say we have succeeded for the first phase?
awesome. Awesome. Look at the big picture first before you
Yeah.
start focusing on the specific technology to make use of. Shiva, any points you would want to add there?
Yeah, again, this depends on, as Kaushik mentioned, whether it is a startup environment or is it a well-established company. If it is a well-established company and they have already huge applications running in production, and then you are building some additional features, so then you may put a lot of thought into various metrics. What is the success criteria for this project? What is the key feature you want to build? So those things come into picture. Whereas suppose you are a startup and you are in the early stages of building your product and then putting into production, right? So then I wouldn't bother very much about kind of DevOps stuff or building high performant architecture. So I would put more focus on what is the one particular feature that is the key feature that your end users are looking for. I would focus on that one. Yeah, if it is a startup company and there aren't too many users, you can worry about the performance later. But you need to validate your idea, and then quick time to market is at most important. So put high focus on building what is the one key feature you are trying to sell to the users. Build on that. That's where I would start.
Okay. So you're talking about the minimum viable product. So figure out what the minimum viable product is. Focus on building that first. Validate the idea, and then probably you can think about a lot of other things. Awesome, cool. Glad to have this discussion on how you set up an application and talk. We talked about a wide range of things here. Koushik and Shiva, any aspects that you'd want to touch upon at the end? Start with Koushik.
Um, I guess it's I kind of mentioned this earlier as well. This is another aspect of being an architect and looking at the team holistically rather than one or two small things. Like everything we talked about, it's not about an individual. And we covered this at the very beginning. When we talked about what does it take to be a successful architect, and it is always about team's success. It's always about partner collaborators team's success. So I think having a big picture is very vital, and but I think that's what makes a good architect. I'll leave it at that.
Absolutely. Thanks, Koushik. Shiva.
Yeah, as an architect, whatever decisions you make today, down the line after 5 years, somebody more smarter than you come along and then say, "Why you pick this stack? Why didn't you make the right choice?" So there will always be that aspect. But one needs to understand that somebody is making a tough decision based on the criteria and the limitations of that particular time. So also, don't try to build some perfect architecture. It should evolve. There is no way you can build something concrete in the first go. It's going to take a lot of iterations and then evolve over time. So as an architect, you have to go with a lot of assumptions and a lot of gut feeling, not just blindly going with something, but you have to take a step. Don't wait for thinking and coming up with the perfect right architecture. You have to make decisions.
Absolutely. So evolutionary architecture, looking at the big picture, focus on the entire team. I think that's the message which is coming across from Koushik and Shiva. Thanks a lot, Koushik. Thanks a lot, Shiva. Thanks for taking the time to be here. I'll see you next week.
Thank you for having me.
Wonderful discussion.
Watching this video is a great first step. How do you remember what you have learned in this video for a long time? Pause, review, and write down the 3 most important takeaways from this video and post them in the comments. What's more, 5 lucky winners win free access to one of our amazing courses. So pause, post the comment, and continue. And do not forget to subscribe. Go ahead. I'm waiting. Thank you. Keep learning every day. Keep learning in 28 minutes.